All right, let's jump right in. We're going to be talking about some of the most powerful, most mysterious, and honestly, kind of terrifying objects in the entire universe. Think of them as the ultimate cosmic monsters, hiding in plain sight simply because they're, well, invisible. Yep, we're talking about black holes.
So, where does it all begin? Well, it all kicks off with this really big question. What actually happens when one of the most massive stars in the universe finally dies? And, spoiler alert, it doesn't just, fade away. Nope, it's the birth of something completely different.
And that something else is, you guessed it, a black hole. So what is it, really? Imagine a spot in space where gravity is just so incredibly strong that to get away, you'd have to go faster than light itself. And since we know nothing can do that, well, nothing gets out. Not a single thing. Seriously, let that sink in for a second. It's like the universe's ultimate one-way ticket.
Okay, so this brings up a huge puzzle, right? It's like a giant cosmic detective story. If these things literally swallow light and don't give off anything, how in the world do we even know they're out there? I mean, how do you find something that's completely and totally invisible?
Right. The first thing to get your head around is what we can't do. You can't just point a telescope and snap a picture of a black hole. It's impossible. There's literally no light to see. So, astronomers had to get really clever. They figured, okay, if we can't see the culprit, let's look for the mess it leaves behind.
So they basically become cosmic detectives, hunting for clues, for cosmic fingerprints. For instance, they can spot glowing gas from a nearby star getting sucked in, swirling around like water going down a drain. Or they can point super powerful X-ray telescopes at the sky and detect this blast of high-energy rays. That's from all the material getting superheated right before it takes the final plunge. And then there are quasars, these incredibly bright centers of galaxies that are basically powered by the biggest black holes in the universe.
All right, so we know how to spot them, but how are they even made? What's the recipe for one of these cosmic monsters? Well, it all starts with one of the most violent events you can possibly imagine, the explosive death of a ginormous star.
And when I say ginormous, I really mean it. We're not talking about a star like our sun, not even close. We're talking about absolute behemoths. Stars that are born with over 40 times the mass of our sun. Only the true giants of the cosmos have enough gravitational juice to pull this off.
You see, a massive star's whole life is this epic tug-of-war. You've got nuclear fusion pushing everything out, and you've got gravity trying to crush everything in. It starts as a cloud of gas and dust, a nebula. Then it ignites, and eventually it puffs up into a supergiant. But eventually, the fuel runs out, fusion stops, and gravity wins. The star collapses in on itself, and then, boom, it explodes in this insane supernova, scattering its guts across space. For the really big stars, the core that's left over is so heavy that gravity just keeps on crushing it, down and down and down, until it becomes a black hole.
But here's a fun twist. It turns out not all black holes are the same. They come in a few different flavors, from the kind made from just one star to the absolute titans that sit at the center of whole galaxies.
First up, you've got your stellar black holes. These are the ones we've been talking about, born from a single dying star. They're scattered all over the galaxy. Then you have the supermassive ones, the galactic black holes. These are the real monsters, weighing millions or even billions of times more than our sun. And you can find one of these giants lurking right in the center of pretty much every big galaxy, including ours, the Milky Way.
Okay, so just when you're thinking these things are all about destruction and the end of everything, we get to this beautiful, kind of mind-blowing paradox. It turns out that the very same explosion that creates a black hole also scatters the seeds of life across the universe. Here's the deal. That massive supernova explosion doesn't just leave a black hole behind. It also blasts all the heavy elements that were cooked up inside the star. We're talking iron, nitrogen, all the good stuff, out into space. And that material becomes the building blocks for new stars, new planets, and, well, maybe even life. Get this, the iron in your own blood was literally created in the heart of a star that exploded billions of years ago. We are, quite literally, made of star stuff.
So that leaves us with this one last thing to think about. We tend to see black holes as the ultimate end, a cosmic point of no return. But what if that's not the whole story? What if that violent, destructive birth is actually a critical part of the universe's cycle of life, death, and rebirth? Are they really the end of a world, or are they the very reason that countless new ones can begin?